Hi everyone, welcome back. Today we're doing delete columns to make sorted. We're given an array of n strings, strs, all of them of the same length. And the strings can be arranged such that there is one on each line, making a grid like this. So for example, if we are given 3 strings like this, then we can rearrange them like this, giving us a 3 by 3 grid. And we want to delete the columns that are not sorted lexicographically. Lexicographically is a jargon that says like in alphabetical order. And in the above example, 0 index, column 0 is A, B, and C. And in this case, the second column C, E, E, in this case are sorted. But for column 1, B, C, A, the lexicographical pattern breaks when it goes from C to A, because in this case, C comes first before A, so this is not. So in this case, we have to delete column 1 and we return 1. So this is the same example that we saw earlier. Is it? No, it's not, sorry. But in this case, you get a grid like this, CDG. CDG in this case is lexicographically sorted. BAH is not, because B to A is not lexicographically sorted. A, F, and I in this case is sorted, so column 0 and 2 are sorted, 1 is not, so we will delete column 1. Delete 1 output over here. So just so it's clear, this is the count of columns to delete, not the index of the column to delete. For the second example, we get A and B. In this case, we only have one column and this column is sorted, so we return 0. For the final example, we get this grid like this. In this case, ZWT is definitely not lexicographically sorted. YVS is not as well. XUR is not as well. So we have to delete all 3. So if n represents the length of strs, in other words, the length of strings, then in this case, where every single item in string is a row or a string, but it effectively behaves like a row. In this case, we have up to 100 rows or 100 strings. And each length of the strs, in this case, this represents the columns. This would be 1 to 1000. And every item in strs consists of lowercase English letters. So we don't have to worry about large and small letter comparison when you do less than equals or more than equals. So this makes things much easier for us. So at this point, we can use one strategy to do that. So the idea is we will be iterating through each of the columns in strs, column by column, and we will check if we will iterate through element by element in column to check if they are sorted or not. And how we do that is by checking if the first row happens to be smaller than the second row in the same column. And if that's true, then we will continue to do the check. But if we notice that by any chance there is one element that breaks the pattern, then we will mark that column to be deleted. And the idea is we will just do a column like scan. So we will scan column by column and we will keep track of a variable that keeps track of the number of columns to be deleted. So with that, let's quickly trace that out. So let's try using this example over here. So you have ABC, BCE, CAE. And over here, we'll be having a simple min deletion. This will keep track of the number of columns that we have to delete. So the first thing that we'll do is for row index in range length of strs. In this case, the length of strs give us the row. And the next thing is the column index. For column index in range length strs at first index. In this case, all strs have the same length. So we can just use the first element to decide what is the length of the column. So in this case, we have the rows and the columns. Now we will be iterating through the columns first. And because we want to iterate the columns first, the column itself, the column index here would be the outer for loop over here. And we'll be iterating through the row index instead. So let's first define, let's first define is sorted, this will be a boolean to tell us whether if this current column is sorted or not. And what we will do here is we have a row index over here. Let's see. We do not necessarily have to iterate through all. Let's use the first element as the anchor. So let's have row index start off from row 0. And we will use the adjacent row below to check whether if the sorted pattern still matches. So to do that, we can just check if strs at row index and column index is less than, in this case, if it is less than, in this case, that means the two elements that we have is sorted. So let me just show you what that means. Row index and column index plus 1. In this case, if this property is achieved, in other words, the first element on top is smaller than the element at the bottom in the same column, then it means that the column is currently still proven to be sorted. So if this happens to be more, in other words, it's not sorted, then what we can do is we can set is sorted to, we can set each is sorted to false, and we can break the circle, we can break this loop over here. But because we are using row index plus 1, we have to be careful to iterate only till length of string minus 1, so that we do not iterate, so that we do not go out of bounds. Because if your row index is pointing at the final index, then row index plus 1 is going to be out of bounds. So you will need to iterate from 0 to length of strings minus 1 instead for the row index. So this looks great. And if it's sorted, if we iterate through the whole column and it is still proven to be sorted, then we will do min deletion plus equals 1. And we will just return min deletion like this. So let's trace this out with our sample test case over here to look out for any logic errors. So now the column index is equals to length of strs, in other words, the first element over here, so range from 0 to 3. So this would be starting off at 0. Is sorted is currently true. And now we have row index equals to 0 as well. So row index will range from 0 to 1. So length of strs is 3, 3 minus 1 is 2, so range of 2 is going to range from 0 to 1 instead. So now we are checking if this strs, perhaps I should leave a comment here just to show you the value of this as well as the value of this, just so that it's more transparent. So for this current element, row index is 0 and column index is 0. So that means it's pointing at A. So this is currently A. And row index plus 1, column index is B. So in this case, we're checking if A is more than B. And in this case, this is false. So we skip it and we continue. So the next thing is to increment row index to 1. So now it's currently at B. So row index and column index is now B, and this is currently C. And now we're checking if B is more than C. In this case, it's not, so this will be false. So we will continue. So at this point, we are done with the iteration here from line 12 to line 17. Now we can move on to column index 1. So now this will be set back to 0, and now we are looking at column index 1. So we're looking at B, C, A. So row index 0, column index 1, this will be equals to B, and row plus 1 in this case would be C as well. So in this case, B is not more than C, so this is false. We will move on, and row index is now set to 1. So now row index at 1 and column index at 1, that is C, and for the element just below it, that's A. In this case, C, in this case, C is indeed more than A, and in this case this would be true. So we have just incremented our we have just, oh sorry, is not sorted. Did I just make a mistake here? Yeah, I didn't miss this during the previous iteration, but we want to increment mean deletion only if the current column is not sorted. So I got that reversed just now. So we are now incrementing mean deletion by 1. So let's set mean deletion to 1 over here. And now we're done with these iterations for the second column. Now we can move on to the final column, column index 2. And now the row index is set back to 0. So for row index 0 and column index 2, this will be set to C. We're now looking at the final column over here. So the element below it is E. So C is not more than E, so this is false, and we continue. Now we increment the row index by 1, and now we're looking at E and E. And because this is not more than E, so this will be false. And we will terminate all of this and we'll return mean deletion as 1. So looks like this algorithm works. Let's implement this. In this case, we are lucky that the tracing wasn't too intensive, so we pretty much were able to implement it over here as we were planning out our approach. So similarly, we are going to define the minimum deletion to keep track of the number of unsorted columns to delete. So for column index in range length strs 0, we're iterating through the columns first, and we're going to define a convenience isSorted boolean. Let's set this to true. And for row index in range length strs -1. So just to remind again, like we are iterating all columns except the final one, because we are going to use this index to compare with the next cell below. And you wouldn't want this to iterate to the end of the row, because if you try to +1 to that index, then we will get an out of bounds error on line 15. So we don't want that. So anyway, we continue. If strs row index, column index, in other words, if this current cell is more than the cell below it, then something is wrong. It means that this current column is not sorted. So we will set isSorted to false, and we will break to save additional computation, unnecessary computation. And if the column is indeed not sorted, then we will increment mean deletion by 1. In other words, we are marking this column to be deleted, and we will return the mean deletion over here. So 0, let's check this through again to be sure that there's no mistakes. So we initialize the variable, we iterate the columns first, and for each column, we iterate through the rows, and we check if a column is sorted by checking every cell and see whether if it happens to be more than the cell just below it. And if that's the case, then we will mark this column as not sorted. And if it happens to be not sorted, then we will increment the mean deletion by 1. So let's run this. This passes the test cases. Let's submit this. And there we go, we passed. So in this case, let's look at the time complexity. In this case, the time complexity, we're going to have, if we let R to be rows, or rather the length of strs, and C to be columns, the length of strs at index 0, it could be any of the lines, but in this case, we are iterating through all columns. So in this case, this would be OC. And over here, we'll be iterating through all rows as well. So this is OR. So in summary, the time complexity is OCR. So this algorithm will scale linearly with either the column length or the row length. And that makes sense because we're iterating through both. So on top of that, let's look at the space complexity. In this case, we are only using variables to keep track of whether if it's sorted, to keep track of how many columns to be deleted, and that's pretty much it. So in this case, the space complexity is O1. It does not scale with the size of row or column. And that's pretty much it for this solution. If you find this useful, Please give us a like and subscribe, and we will see you in the next video.